Good evening, lecturers and beloved friends. Today, I would like to introduce the assignment Smart Grow Plan in Group 11. So, for the task delegation, we will include 4 sections. The first section is Bluetooth HC05, and the second one is GPIO input push button, also with active buzzer. And the third one is capacitive soil moisture sensor and soil moisture sensor. And the last one is LCD. So, 4 of us will divide it separately. Besides that, we will having the physical meeting at S01 for setting out the materials. And the second place is College 9 to trying the materials. And the last one is at P19A for recording section. In this project involve 4 inputs and 4 outputs. So the first one, for input, GPIO input push button, capacitive soil moisture sensor, Bluetooth HC05RX and TX, UART input and output. And for the output, LCD 16x2 display I2C, UART communication, Bluetooth HC05RX and TX, GPIO LED on or off, GPIO active buzzer BWM.
My name is Herxuan, and I would like to present an important part of our project, which is the soil moisture sensor. There are 3 different colors of LEDs, each representing different soil moisture levels. Now, as you can see that the red color indicates that the soil is too dry and needs watering. Now, the green color LED indicates that the soil has sufficient water and does not need any watering. The blue color LED means that the soil has too much water and should not be watered anymore. Okay, right now I would like to present about the capacitive soil moisture sensor, which is used to measure the moisture level of the water content. As you can see, there are 4 LEDs, each indicating a different level of moisture. At the beginning, with very low moisture level, the red LED lights up first. And when the sensor gets deeper into the water, the LED lights also starts turning colors, eventually turning on the blue color. This indicates that the water moisture level is getting higher and higher. The results are successful.
So the purpose of this project is to implement an input push button as a user interface that enables manual control or smart program system, such as changing display mode and trigger specific system function. So now I will connect power to the circuit. And then I press the button using the pen and the LED will turn on. The project involves coding to control an active buzzer using PWM, pulse width modulation. The code generates a PWM signal on TIM2 channel 2, adjusting its frequency and duty cycle in a loop. The period of the PWM signal is modified using the auto reload register ARR, and the duty cycle is controlled with the compare register CCR2. The PWM characteristic change gradually in each loop iteration with 100 millisecond delay between updates. Finally, the coding is successful.
I want to present about Smart Grow Plan SGB. The purpose of this project is the LCD display our group name and the project title, allowing users to clearly identify the system and its purpose. The results successful.
This project involves coding to control GPIO output, LED on or off, and UART communication with Bluetooth HC05RX input and TX output for data exchange with a phone. The code used an interrupt-driven approach to handle incoming data from the phone, checks for N or Y in the received data, and controls a GPIO pin, turning the LED off for N and on for Y. The UART received interrupt is used to efficiently listen for data while allowing the system to perform other tasks. Finally, the coding successful.